Okay, so good programming practices. Now there is a full, in fact there are courses on software engineering. Okay. So the big codes require a lot of teamwork, also a lot of discipline, and they are tools. So Linux operating system, no. So the Linux operating system, if I know correctly, it is 15 million line of codes. Okay. And there are for Linux probably there are 1000 developers. So and they work simultaneously. Now imagine one code here can do something there. So there are a lot of tools available to make sure that the codes are not conflicting with each other and so on. Okay. So but we will adopt some of those strategies. I am not, in fact I can't write operating system myself, and I do not expect any one of you to do it, but if you are doing it, great. Is very good thing to do if you are good at it. So we will just look at some of the strategies which is used for big codes. By the way, some of these codes which which use supercomputers are big codes, like our own C++ code is around 100,000 lines. Okay, so these codes can grow in size. The weather forecast codes will be definitely 1 million lines or more, or probably more, actually several million lines. Okay. So we need to do planning. So these big codes you do not start away start writing. Planning even for moderate code, something like which is 100 line code or 1000 line code, you should think before you start. And for weather forecast is much more planning. You need to build a team of experts who do not code, but people who code, and the computers. So it requires huge planning if you are writing a big code. But even for moderate code, you should not say that, well, I can be indisciplined if I write 100 lines of code. You should be disciplined even for writing 100 lines of code. So the things which are stated, by the way, these are by computer scientists who are stars of programming. They state the problem statement, problem size. So you need to have your problem statement stated clearly. Okay. Without that you should not go to program. For us, we should have problem size as well as boundary condition, which time stepping, all that should be thought about before you start to code. How much accuracy is required, okay, and you need to choose appropriate time stepping scheme based on the accuracy, and work out the solution on paper. I have seen most students just start typing def or some for I equal to 1 to 100, should never do that. Okay. So you should first write down, jot down a piece of paper and work out your solution. If bigger problem, then you need a notebook, okay, different papers, but small problem also you need to put it down on paper, think carefully and patiently. Okay. So coding is very easy if you have your algorithm and your thought process clear. In fact, what's his name, Straub, the C++ developer, he started C++. I think it's Straub. I forget his name. Okay. So there is a line which I kind of really like it. If you can code a certain program, if you can code some problem, then you understand it well. I hope you understand this part. So if you solve Schrodinger equation on a computer, then you really understand it better than scribbling on well exam paper or your notebook. You will have to really think about the problem when you code it. Okay. So so this is you can't be a good, the program can be good, cannot be a good cannot be a good program, some code, unless it is written carefully. Well, some more thing I can just say that you should not use like there are people for variables x1, x2, x3, x4, x5. I have seen the codes. They just write variable names are just x1 to x50. You should use variable names properly. So, if velocity, then use velocity as a variable name. Okay, do not use x as a variable name for velocity. Okay. Loops, the index should be, we should have discipline, I, j, k, and once you freeze it, for every loop we should also use I, j, k. Okay, so, and these are some simple stuff, but they are very useful. We need to decide which hardware. So, if your program does not require a big machine, then you should not use big machine. I have seen people like they have code which is written by somebody, some disciplines, and you just okay, naya computer aaya, so new computer has come, so you just you have so much quota, just run it, and so that is a very bad way to use a machine. So, something can be done in a PC, great, no problem. You do not have to show off that I run a supercomputer. So, this is in terms of increasing power. PC, server is a workstation. Okay, I am sure you have seen workstation, right, which is not desktop. It has better processor, more RAM. Okay, and normally server should be in an air conditioned room, but PC need not be. Cluster, okay, which is like our Sanganak is a cluster, and GPU. It can, single GPU is also good. It, in fact, as I told you, single GPU can do as good as 1000 CPU cores. So, if you have GPU, then you use them, or GPU cluster. Okay. So, also nowadays is interestingly or unfortunately you can get an international account. Okay. So, if your code is good, then you can apply for saying that I want to run on the best machine in the world. It is possible. So, we had this Shaheen account, we had several other accounts. So, in India we had machines, in ECA we had an account, in CDAC machines. So, you just had to have good code, then they will give account, but they will not give account to anyone. So, you need to show that you have a good code, and you need to work, not that you can get an account as just like that. Okay. So, software, so decide software tools. Okay. So, basically I am going to discuss this part a bit more, which language, which library, So, not every code you should write, like FFT which we use, well, some FFT we wrote ourselves because we did not have a FFT which we wanted, but part of the FFT is what we use, which is already available library. So, FFTW. So, this is short form for fastest Fourier transform in the world, in the West, sorry, not in the West, W for West. So, this is developed in MIT. So, in the beginning I was used FFTW, but then FFTW had certain limitations. So, we said, well, we need our own FFT. So, that is where we made FFTK. So, this K for what? Kanpur, which is the FFT Kanpur. Okay, so this is a PhD student Anando Chatterjee, who's I showed you the scaling. This is FFTK scaling. So, so basically, do not start writing FFT if you will have written already, and if it is good enough for you, then you should just use it. Okay. So, these are the library we use for our C++ code. Blitz++ is a very good library for vector operations, vectorizing. So, C++, the native C++, native means the original C++. It does not vectorize arrays. So, we needed an array library, and this is a very good library, Blitz++. And there are other ones like Eigen is another good library for solving matrices. Eigenvalues is very good. FFT, and there are like for Python I can convert directly to GPU. Okay, so one student Somdeep, he is very good in converting Python code to CuPy. So, everybody I am sure does know about NumPy, right. So, in fact, you need to replace NumPy by CuPy, and lot of these array operations are available in CuPy, for GPU. So, conversion of your sequential Python code to GPU is very easy. Okay. So, you do not write your own array library for GPU. Okay. So, it saves you time, you can solve your problem quicker, and never expect that the other people are stupid. So, they are very good programmers who have developed extremely useful tools. So, which programming language? This is a critical question. Now, this has changed over time. So, by the Fortran was the first programming language for higher level language, where the computers were designed for scientific computing in the beginning when 1950s. So, weather forecast was one of the first application which was thought for supercomputers. Okay. So, this guy called Manabe, you might have heard, he won the Nobel Prize. He was probably one of the first users for scientific applications in Princeton. Okay. So, Fortran was the first language, high level language, but then business makes more money than science. So, then IBM and all that came and then started making things for business, like COBOL, banking, and so okay. So, that time only Fortran was available, but now later other languages came. So, C is very powerful language, but that was designed for operating system, okay, for writing drivers. So, computer scientists, they love C, okay, that is what they write, C. But it was not good in the beginning for parallel programming, for scientific computing, because they did not have the libraries. For example, Fortran can do log, is part of the Fortran, but in C it was not available. The separate library was written for log. Some things are not fast in C++, many of the operations are slow. So, you need a library. So, until these libraries were developed, these languages were not C, C++ were not very good for scientific computing, but now people have developed them. Okay. So, presently I am not going to dig deeper into which is good and which is not good, and some of it is personal. Okay. So, I have preference for some language which you may not have for that language. So, and also there are new languages which are coming up, Julia, Ruby, okay, but so you can choose, but I can make one comment. Well, I think it can go recorded. So, the thing which starts first gets more, in fact, it picks up more mass or more followers than people, the things which come later. So, like Windows, I can definitely say that Windows is worse than Linux in terms of security, file structure, okay, virus protection, right. So, but still Linux has not that many users, because Windows started before and people do not want to change. One more thing is, however great new things would be, people are very reluctant to change. So, that is why C, C++, Fortran, they are hard to displace. So, many of these US weather forecast codes are all in fact most of them, the big codes are all in Fortran. Okay. Though Fortran does not, to me does not look like, does not seem to have big future in the with this new hardware, okay, but it is in Fortran and people are reluctant to change. Okay. So, anyway, so that is lot of this language is a big issue, and it is not $1 million. I mean, people, there is so much of investments goes into this code, and once you freeze, then how to change, you know. So, those codes which are written with so many people, only, I mean, you want to replace the language, it is going to be extremely difficult. Okay, but and these are choices. So, which language you should choose is a very difficult thing, and well, as maybe you guys will become some group leaders, then you need to take a decision. So, my take is that Python will stay with challenge of Ruby, Julia or Ruby and all the language. So, Python will stay for quite some time. Okay. It has basically Fortran and C has is challenge for Python, but Python has some beautiful features. It has very good library, it is interactive. Also now with AI and ML support. So, AI and ML softwares are basically the libraries are all in Python, though the inside it is in C. Okay. Like FFT is written in C, but you can call using Python. So, the ones which you need very fast, it is written in C, but you can easily call, integrated well, and these GPUs are being designed for some of those stuff which can be used by Python. So, Python is a extremely useful language to learn and master. So, the languages, so this is called interpreter language. Now, I will not get into this, at least at this point, maybe not in future as well, and these are called compiler languages. Okay. Now, well, maybe I will make one line. The compilers are typically optimized, the compiler output, because compiler looks at the whole code and then it knows, okay, the user did not specify very well, but I can optimize this part. So, compiler output typically is faster than interpreter output, but Python interpreter now, if you give the full code and if you use lot of efficient libraries, it has as good performance as C. Okay. Now, we have it, we have the numbers. Our code written in C++ is matched by Python code. Okay. So, Python has picked up, but it has to be designed well. If not, then it will not work well. Typically, Python will be slower, much slower. So, these are the well, scientific languages, but as I said, there are some more new ones, and I recommend Python and C++. Okay. So, you can't learn all the languages. In fact, it is going to be counterproductive. You should not learn all. Fortran and C++, they are basically very different style. So, but yeah, anyway, so I recommend these two languages. C++ has very good features called this object oriented programming. For large codes, it is a very critical thing. Okay. You do not want to write too many files, unconnected variables. So, I will discuss a bit of object oriented, why it is useful, and writing large codes in C++ is easier because of this object oriented. Okay. And it is used, I mean all this bank software also, they are all C++, not in C or Fortran. It has also many useful features, functional overloading. These like so sum, I am summing, well, I write a function sum for, so sum, if I have integer arguments, then it will give output, but in Fortran, if I want to write a sum for floating point variables, then the same name cannot be used. As well, the sum is used for integers. So, by the argument type is also useful, important for Fortran and C, but in C++ you can overload it. By seeing the argument, it knows that it is a different function. So, this is the function overloading. Okay. Virtual function, classes, these are extremely useful tools for large codes. By the Python is nice that way. Sum, I can put any argument inside, in fact arrays also. So, function overloading is some sense it is implicit, unless you put a structure inside, then there is a problem. Object with well, we have this problem with objects, function overloading of Python with objects, that is not possible, but with Python is pretty simple to learn and program. Okay. Python is fast now, well, programming is fast for sure. So, our C++ code, which has more features, definitely 100,000 lines. Okay. Python, we have basically at least half the features, not all the features C++, it is 3000 lines. So, we know that difference, and it took me several, well, probably 10 years to develop the code to that level, but Python was developed in 6 months. In fact, we started with one of the course and we just took up, and it got built in 1 year it was ready. So, Python development is very fast in comparison to C++. Okay, so, so these are something which I already told you, this float operations in C++ is very slow compared to Fortran, but there are libraries. So, like this is a very good library, Blitz++, Eigen is I said, Boost. Okay, so we use this Blitz++ for our C++ code. Now, for GPU, you have C++ sequential code, you can push it in GPU by the OpenACC. So, well, CUDA will be the best thing to do if you want optimized code, but you do not have time or you do not have skills or you want to do it fast, then you need to put some compiler directives. So, I am going to tell you what is compiler directive a bit later. So, it is tells the compiler that do this. So, it is compiler directive, the compiler is directed to do something. So, these are easy thing to put, and you can get a GPU code which can give you a speed up, significant speed up, maybe 100 times, which is great. I mean 100 times speed up on a GPU with maybe 2 weeks of effort. Okay, Python and C++. Python is interpreter language. Okay, interpreter is okay. So, language interpreters, I mean a prime minister is speaking to Russian president, then the interpreter will line by line translate it. So, that is the interpreter. So Python line by line it is converted into object. So, here it is conversion from higher level language to machine level language is done line by line, and that is why it does not, sometimes it is not optimized, well often it is not optimized, because one line is already compiled and next line has some relation, but since already compiled, the interpreter does not know how to relate the two, it is already done. But if it is full code, then interpreter can do something, now they are optimizing all that stuff. But C program is C programs are compiled. So, the compiler looks at the whole code. So, just imagine that somebody is interpreting line by line, some messages can be misinterpreted, but you compile the whole page, then you can correct, say well 2 lines mean this rather than 1 line means this, 1 line means this, and compilers are very clever. Okay, so compilers are can really speed up codes. In fact, just by using compiler option -O3, you can get a speed of factor 5 or factor 3. So, you need to know some of the options, and you definitely should use one of the options, -O2 at least. It takes bit longer to compile, but it gives you speed up right away, because it goes through iterations. It goes one loop, then say well this variable was there, so then it goes another loop, so it optimizes it. But coding in Python is fast, I gave you example myself. So, we can write Python parallel code in Python now, is available. Earlier it was not, but these are new development. Last well, things were available in the past as well, but now they are pretty much streamlined. MPI is available for Python. In fact, the syntax is much simpler than C++ syntax, and we will do this. In fact, we will focus on parallel code in Python. Okay, so that is in this course we will do this, and we can call efficient C++ Fortran code in Python. Okay, compilers. So, which compilers are available? I am just going to name give some names. So, GNU compiler for C is GCC. Okay, Fortran compiler is I believe G90 something, G90, G95. I do not know. Okay. So, these are new C compilers, do not worry about it, CLang and LLVM. Intel compilers for all Fortran C is available. Cray has its own compiler. PGI, I think this is bought by NVIDIA, I think somebody has bought this PGI now. They had good compilers, and NVIDIA has its own compiler, AMD has its own compiler. So, these companies they have their own hardware, I mean ROM, Xeon. So, this compiler is a slight edge for their own hardware, but not so much. I mean, we find that Intel compiler and GCC compilers roughly they give the same speed. Okay, it could be 10% faster, but not factor 3 fast. By the way, the 10% can be very critical. Okay, so you should always check, look for some speed up. Something which takes 1 year, it can be done in 11 months. Okay, which is good, right? 10%. So these libraries we need it for this course. Now, fortunately, MPI was already available for last 20 years, but OpenMP was not available very easily but now it is available in GCC. We use GCC, it's free and it works on all platforms, so we use GCC. Intel, by the way, Intel compiler is not available for free, you have to download and compile, but this may not work on ROM because ROM is different company. So, all that hassles are there if you use proprietary software. MPI, there are two popular ones, OpenMPI and MPI CS3, but we recommend this one right now. Okay. Cray has its own MPI, Intel has own MPI. For Python, the MPI is this MPI 4Py. Okay. So, this is a package like NumPy. Okay. So, you can import it and then write your send, receive, all that stuff. So, testing is a very critical operation for any software development. Test thoroughly. This is the place where everybody slacks, including us. Okay. So, we do not test all possible things. Now, the code is already developed 2 years back by some student has gone somewhere, suddenly find that it is not working well for some data, some input. Now, you have to figure out why it is not working. So, because some boundary condition was not handled properly, it is crashing or it is giving wrong results. So, that is a pain, no? I mean, you expected something and you do not know, and developer is not around. So, in the beginning itself we should test properly, especially for the boundary conditions or for the extreme cases. The code which works for positive viscosity may not work for 0 viscosity, most likely it will not, but then you should see whether it can work for 0 viscosity. Okay. Sometimes, for example, simple stuff, we had this A50 was working fine. Now, we kept pushing the grid up, and it went to 4096 cube, it broke, something was odd, because the array size itself in integer 32 bit was not 4096 cube, it was going beyond the bound. Okay. So, we need to use a double into something. Okay. I do not remember now. So, that kind of things can happen. So, you need to be testing should be thorough. Test against exact results. So, by the way, you should test against exact results. For example, energy is conserved in Navier-Stokes equation with viscosity 0, or for Schrodinger equation you should get mod psi square dx equal to 1. Okay. Well, it will not get exactly 1.000, but it should be up to 6 decimal places. Okay. So, test against limiting cases, as I said, and keep testing frequently. So, because there are changes in the code and there will be, so if once you make a change, then something else will get affected. Okay. And then suddenly that is what happens, it starts, one module does not keep working. In our code, we are proud of it that our same code can work on fluid, magnetohydrodynamics, temperatures, it can do all of it. Okay. Many applications which people write separate codes. You have one code which can do all, but once you put temperature, then something of fluid stops working. You know, some indirect connections, and then so we need to test thoroughly. Well, so there are automatic testers, the auto tester scripts which you can write and that can test. So, that means for this input I should get this result, and you should keep checking every 6 months or every month. So, this is another important called versioning system. So, when we make update in the code, then we should preserve the old one as well as the new one, right, because as I said the new one has some bug. So, I need to compare what changes were brought in the new one, and from the difference you have to figure out what change, what is the problem. And you might have seen, no, I mean for Python or for Linux, Linux 3.2.1 they write like that, and what does that mean? Is version 3, sub version 2 and sub version 1. So, major version is like Python version, right now we follow Python 3, right. So, which version? Python 3.6. So, that is 6 of 3rd. So, this versioning is important. So, there are very standard tools now, GitHub offers you this. You can keep pushing your versions, you may not number them, but you can go back to 1 version, 2 versions before, and it is free. Okay, GitHub is free. A lot of things are free. GCC is free. So, we have free softwares. Blitz is free, so we can use quite a bit. So, building codes. So, that is another important issue, which is if you have large number of files. In this course, well, I mean we will not have experience of building such codes, but when you become a professional programmer, we will deal with at least 50 or 100 or even more. So, they are all compiled by automatic tools called CMake and Makefile. Okay. So, so we do not, well, GCC file 1, file 2, file 3 you can't do it, they are dependencies. So, so the dependencies are handled by CMake. I will not cover in this course, but you should know that there are some tools available. So, you understand, no, dependencies. So, the innermost program, then there layer on top which will use that library, then there another thing which will use other library. So, you have to compile the bottommost first, okay, and after that the next will compile. Otherwise, this guy, if you compile the top one, is, well, I do not know what they mean, what those functions mean. So, that is why it is called CMake will handle it. Open or closed is a big debate. So, there are commercial codes and there are open source codes, like GCC is open, but if you write your own code, should you open it up or not? Okay, whether if it is simple code, nobody cares, but if it is a large code, then the issue comes. Okay, so we had kept our code open, Tarang was open, but we are trying to now commercialize it. So, these are decisions one has to make. Open source codes have, well, basically you do not have people to support the open source code. So, some user knows, I want to use your code, but give me help, and we do not have any person to help, then we need to hire somebody, but who will pay for that engineer. So, all these issues come into when you develop large codes. Licensing. Okay, so, by the way, even open source codes are protected. That means, tomorrow somebody cannot use the same code and put their name on it. So, there are license, various sorts of license, or they do not put their own name, but they can use it for something bigger or something else. Like our FFT library can be used by somebody, but then under which license? There are some licenses which say, well, you cannot use it for build something of your own. You understand what I am saying? So, using Blitz we could develop our own library, but Blitz has a license which says we can use this code and build something, but if Blitz says you cannot build something on top of it, then we can't use that library. You can use it only for doing that particular whatever it does. Okay. So, these are licenses which we need to know, and this I think I am overstepping, but let me finish this part. This is our own development. So, Tarang is a example I can tell you, which I spend a lot of time, and our students in the lab too. So, this is these are developers. I was a developer in the beginning, then the PhD students, Anando, who is an engineer now in a CC, he contributed a lot. So, in fact, the FFT library, he is the main guy, FFTK, and I started this on 2004. Okay, just to give you the example, this was very long time effort, and the C++ is 1 lakh line codes. Python, as I said, is around 3000, and CUDA is also very big. Okay, this is Manthan and this is Somdeep. So, once you have the code, then developing that different language is not so difficult, but we have to be at it. I mean, we were kind of forced to rewrite it because GPU came. Now, C++ code does not run on GPU. Okay, so, but it was a good thing we changed because we can now use GPU and our code is very fast on GPU. By the way, our FFT, the GPU FFT was the first FFT, multi-node, multi-core. NVIDIA has its own, but it is closed source, and before NVIDIA released that, our library was ready with students. And this code is a single code which can do all this many applications, rotating turbulence, fluid. So, this happened because of object oriented design. Okay. So, I can say that our code is a general fluid dynamics solver, in fact general PDE solver of certain type. So, we solve this du by d, well, let me call it dx by dt is Laplacian x plus I can put a vector or a scalar, or let us put a vector here, x dot grad y. Okay. Now, x can be velocity field, x can be magnetic field, x can be some other field. So, we put this variables as a general variables, and we write down this kind of operation also y dot grad x. So, we have these operators written, functions written for them, and you can combine them to write a new solver, okay, new application. So, this is what it can do, and why we have single code rather than many codes? Is it a good idea to write a single code which has some problem that if you change some part it can affect the other part, but it has advantage. Advantage is that I have single code with which I can solve and lots of problems. So, for us to write a new application is 2 weeks work, okay. And we start from scratch, it takes 6 months to work, and lot of this postscript operations, okay, like for example, we can compute some spectrum and so on, they are all will work for any application. So, I always prefer one library compared to one code compared to many codes. Maintaining many codes is a problem, right. Maintaining, you understand, no, when somebody asks, well, basically somebody asks you, okay, can I use the code, and then it should work properly. And if you are, let us say 10 codes and we are not sure this code is working well or not, because nobody used it for 1 year, but this code is used by the lab, so it is kind of active. Okay, so well, by the way, Google is a very good source for help, huh? So you can just Google and you get answers. Something is, in fact, I had some bugs and can't figure out what the bug means. You type the full bug within quotes, and you will get some reply. Somebody has put somewhere, and that seems to work. So, make the code better and better. So, we kept changing workshops. So, we ran on all possible computers, and I mean there is one thing which I do not have, at least, is fear. Okay. So, we should keep pushing. So, we ran on the full machine, like Param UA, when it was running on the full machine, it used to shut down because it gets very hot. Look, when you have 4 processes running, 4 jobs running, then some guys will be not working, right. I mean, when all of them are running, then it becomes it generates a lot of heat. Okay. So, you should always push it to the limit. Okay. That is like in sports people do it, but okay, we do it in programming, and many students contributed. So, there are, well, not only the coders, the testers are very important part of software development. Okay. So, people who test and say, well, it does not work, this works, that is very critical. Okay. So, our code is, I would say, is one of the best, well, probably the best spectral solver in the world. Spectral is finite with Fourier transform, and its design is very good. Okay. And so, I got this award for this code, and you can read this. I thank a lot of people, but anyway, it is development work. So, it is really teamwork. We need a core team. Also, this strategy has to be adopted. I am not very good manager, but we take help from whoever comes. So, core team, part-time developers, testers, users, documenters. We do not have documenters. Okay. Advertise. we need a good manual, which we do not, we have some manual, but not good website, social media. So, I am telling you that if you develop codes, and you should do it, you should pay attention to this. Conduct workshops, this is a critical thing. And so, there are two types of workshop, developer workshop and user workshops. So, developer workshops can contribute to the code, okay, and spread the word around. Okay. So, this is one more last slide, exascale challenge. So, our code runs on a petascale machine, that machine is, I think Shaheen was 6 petaflop, and it ran on that machine, but now can it run on exascale machine? Okay. Now, it is not clear, because FFT is not great for with large number of cores. You can saw that with GPU scaling was not good. Okay. So, we do not know, if you get an opportunity we will try it, but it is a issue right now. If you have a code which can run on exascale machine, great, you become famous. And so, whether people need that kind of code. So, simple addition of arrays is not good. You have a big code which runs on all of it, then you know that okay, it took all the complexity, it handled all the complexity. So, for example, UI used to shut down. Okay, we know it because you are sitting there and you will just shut down. Okay. So, optimization. So, basically right now we need to be very good in software as well as software understanding and hardware understanding. And so, as I said, good require knowledge of hardware and software. And so, this is an article which I have written. They are available in my website. If you are interested, you can download this article. It is a very easy to read article. So, what are the complexities for exascale computing? Okay, so let me stop here. I exceeded the time, but